Class 11th Chemistry Unit 4 Chemical Bonding and Molecular Structure, and in this video we will discuss about molecular orbital theory, that is MOT, and linear combination of atomic orbitals, that is LCAO. First come to molecular orbital theory. It was developed by F. Hund and R. S. Mulliken in 1932. The salient features of this theory are: the electrons in a molecule are present in the various molecular orbitals. Like in atom, electrons are present in atomic orbitals. The atomic orbitals of comparable energies and proper symmetry combine to form molecular orbitals. Molecular orbital is polycentric. Now, what is the meaning of this polycentric? The electron in a molecular orbital is influenced by two or more nuclei depending upon the number of atoms in the molecule. In this way, we can say atomic orbital is unicentric because there is only one nucleus is present. But in case of a molecular orbital, or we can say in molecule, more than one nucleus is present. That's why electron in a molecular orbital is influenced by two or more nuclei. Such type of molecular orbital is known as polycentric. The number of molecular orbital formed is equal to the number of combining atomic orbitals. When two atomic orbitals combine, two molecular orbitals are formed. One is known as bonding molecular orbital, while the other is called antibonding molecular orbital. The bonding molecular orbital has lower energy and hence greater stability than the corresponding antibonding molecular orbital. The electron probability distribution around a group of nuclei in a molecule is given by a molecular orbital. The molecular orbitals, like atomic orbitals, are filled in accordance with the of-above principle, obeying the Pauli's exclusion principle and the Hund's rule. These are the important points of molecular orbital theory. Now come to formation of molecular orbitals. We have discussed that according to quantum mechanics, solution of Schrodinger equation gives the wave function, and these wave function describe the atomic orbitals. Okay, but to solve the Schrodinger equation for a molecule is very complicated. That's why one approximate method is taken, and that method is known as linear combination of atomic orbitals, that is LCAO. This is an approximate method to obtain wave functions for molecular orbitals. Consider hydrogen molecule consisting of two atoms of hydrogen A and B. Actually, hydrogen molecule is formed by two hydrogen atoms. Okay, and these hydrogen atoms we are representing as A and this one is as B. Okay, each hydrogen atom in the ground state has one electron in 1s orbital. We can say electronic configuration is 1s1. The atomic orbital of these atoms may be represented by the wave functions psi A and psi B. We can say psi A is the wave function of atomic orbital present in this hydrogen atom, and psi B is the wave function of atomic orbital present in this hydrogen atom. Mathematically, the formation of a molecular orbitals may be described by the linear combination of atomic orbitals that can take place by addition and by subtraction of wave functions of individual atomic orbitals as shown. This psi MO, this representing the wave function of molecular orbital. Okay, and this is obtained by the linear combination of wave function of psi A and psi b. That's why we can say psi MO is equal to psi A plus minus psi b. That is, addition and subtraction of wave function of atomic orbital gives the wave function of molecular orbital. The two molecular orbitals sigma and sigma star are formed as, that is, sigma is obtained by the addition of wave function of atomic orbital psi A plus psi B, and sigma star is obtained by the subtraction of wave function of psi A minus psi B. Okay, the molecular orbital sigma formed by the addition of atomic orbitals is called the bonding molecular orbital, while the molecular orbital sigma star formed by the subtraction of atomic orbital is called anti-bonding molecular orbital. We already discussed that is when two atomic orbitals combine, two molecular orbitals are formed. Out of these two, one is bonding and another one is anti-bonding molecular orbital. Now let us see this diagram. This diagram representing the formation of molecular orbitals. This represents the atomic orbital of atom hydrogen A, and this representing the atomic orbital of atom hydrogen B. When these two will combine, we will get the two molecular orbital, this one and this one. This molecular orbital, which has lower energy than the combining atomic orbital, is represented as sigma, and this is known as bonding molecular orbital or bonding orbital. It has lower energy than that of atomic orbitals. Okay, and this sigma star, this represents the anti-bonding molecular orbital or anti-bonding orbital. It has higher energy than that of atomic orbitals. Is it clear? Now, what are the differences between bonding molecular orbital and anti-bonding molecular orbital? Bonding molecular orbital is formed by constructive interference of the electron waves of the combining atoms. Constructive interference means we can say that is addition of wave function. Okay, while anti-bonding molecular orbital is formed by destructive interference, that is subtraction of electron waves of combining atoms. In case of bonding molecular orbital, electron density is located between the nuclei of the bonded atoms, because of which the repulsion between the nuclei is very less. While in case of anti-bonding molecular orbital, most of the electron density is located away from the space between the nuclei, hence the repulsion between the nuclei is high. Electron placed in a bonding molecular orbital tend to hold the nuclei together and stabilize a molecule, while electrons placed in the anti-bonding molecular orbital destabilize the molecule. Bonding molecular orbital possesses lower energy than either of the atomic orbitals that have combined to form it, while anti-bonding molecular orbital possesses higher energy than either of the atomic orbitals that have combined to form it. Bonding molecular orbital does not has nodal plane, while anti-bonding molecular orbital has a nodal plane. These are the differences between bonding and anti-bonding molecular orbitals. Now, conditions for the combination of atomic orbitals to form molecular orbitals. The combining atomic orbitals must have the same or nearly the same energy. The combining atomic orbitals must have the same symmetry about the molecular axis. By convention, Z axis is taken as the molecular axis. For example, 2pz orbital of one atom can combine with 2pz orbital of other atom, but not with the 2px or 2py orbitals because of their different symmetries. Okay, the combining atomic orbitals must overlap to the maximum extent. Greater the extent of overlap, the greater will be the electron density between the nuclei of a molecular orbital. These are the conditions. Thank you. Subscribe my channel to get the new videos. In the next video, we will discuss about types of molecular orbitals.